Record. Well, we will take some of the questions from the boys and one question from the girls. It will be a random question, so I want any one of the boys who will want interested to give a, if he has a doubt, that question he will give, and we will try to solve it in all the 5 different methods. And I will specifically start with the Thevenin theorem and superposition theorem. Thereafter, I will go for the mesh and node analysis if time permits. Is it okay? So, anyone? Yes, you have a doubt, right? Okay, you want to draw it here? Aja. And also, I want to take it anyone from the girl if they are interested. Either you can draw or I will draw it. You are also interested. You are also. We have a space, so both of you please come. So you draw here. Are you comfortable for there? Or you chalk? Do. You draw your answer, question here, and you write your question there. Okay. So we have got 3 questions from the boys. We will solve all these 3 questions in Thevenin first. Okay. They will write the question. Let me verify whether the question is correct or not first. Then they will specify the load. Maybe any one of the load is there. Maybe one, whatever the load they will specify. Then our challenge is to solve it by using Thevenin theorem. Correct? Thereafter, our challenge is to solve the same thing using superposition theorem. Norton theorem we can do. However, it is not in your course. So still we will do it. Okay? So all it depends on the time. Within 15 minutes, 15 minutes, how much we can solve, that depends. Girls, you ready with your problems, right? So we will quickly solve it. Within 15 minutes, I will try to solve. Do you want to solve it? If any student is interested to solve, most welcome. So that's why I said any 3 students will give the questions. Now any 3 students are welcome to solve this problem. You 3 have drawn, na? Yeah. Take your seats. Thank you. They have taken a lot of difficult problems there. Okay. Okay, you go. Okay, go. Here also. Okay, we'll start with him first because he is what is the value of the current source? 5 ampere. And which one you want the load? Which one is the load here? 5 ohm. Is this the load? Yes? Okay. Let me redraw it. Here we are redrawing the same circuit once again. This is 1 and this one is 20 volts. Is it right? Everybody, are you satisfied? This is right transformation, right? We have just redrawn the circuit. Right. So whenever you get a question like this, first of all, please redraw it in a better way. Otherwise, you will be confused, or a lot of circuits are there, it's looking like a triangle and what to do, all those things. Okay, so I'm going to rub this place. This is okay, let us remove that. So here we have the load. This is the load we have. And we want to solve it by using Thevenin theorem, right? Have you solved it earlier by using node analysis? Okay, you're not sure. So first of all, please solve it using, okay, let us say solve it using node analysis. One group will solve using node analysis. One group will solve using mesh analysis. So this side of the student, you mesh. Okay, you solve in mesh. This side, node, right? Okay, you solve it using node. I'm solving using Thevenin. After that, I will explain you, right? I have just tried to draw the, find out the Thevenin equivalent, RTH. And to find out the value of RTH, I have redrawn the circuit and removed the current source from here and make it open, and all the voltage sources are 0. And name this terminal which is removed as A and B. And RTH is nothing but RAB, and that is equals to 2 and 1 are in. Anybody is there who is not doing in neither mesh and neither node? They are welcome to do with the Thevenin theorem. Okay, so if you are doing with the Thevenin mesh analysis, go on. You do with the node. Those who are not doing either of them, they please come do it as a Thevenin theorem, and please correct me wherever I find it, you find it wrong or somewhere. Okay, here 2 and 1 are in parallel and 1 is in series. So it is 1 plus 2 into 1 by 2 plus 1. That is 1 plus 2 by 3. That is 5 by 3. So the value of RTH is equal to 5 by 3 ohms. So let me just zoom it up. Okay, first thing is that you find out the value of RTH, and the first job is over. Second is to find out the value of VTH. For the VTH, let me just redraw the circuit once again. Let the same circuit is used as A and B. I can reduce the circuit again. This is as B and this as A. So this looks like only two meshes there. We can use it a mesh analysis and solve it. or you can use a node analysis and solve. It is better to solve using the mesh analysis because we have a current source here. I1, I2. Intensely we take it at anti-clockwise so that the I1 current is known to us. I1 is 5 ampere. And we need to write down the equation for mesh 2, and that is equal to minus 10 plus I2 plus 20 plus 2 I2 minus I1 is equals to 0. So if I solve this equation once again, the same equation can be written as 10 plus I2 plus 2 I2 minus 5 is equal to 0. So here it is 3 I2 so it is 0. So I2 is equals to 0, right? Okay, we get this answer, I2 is equal to 0. Let me just zoom this up. Now we need to find what is VAB. Let's move from A to B. Let's move from A to B and let us choose a path like this. We are moving from A to B, taking a path like this. So it is coming around as 10. Then we have got 2. That is I1 minus I2. Then we have 1 into I1. That's all. 10 plus 3 I1 and I1, what is the value of I1? 5. 10 plus 15, that is 25 volts. So we get the value of VAB. Now what is the value of current? The load current is equal to VTH by RTH plus RL, and VTH is nothing but same as VAB, that is 25 divided by RTH 5 by 3 plus 5. So this is equals to 20. The current through 5 ohm is coming around 15 by 4 ampere. Mesh analysis, what is the answer? Node analysis, what is the answer? You are doing in which one? Node? Okay, do it. What you have done? You have done in some, have you done this problem? How much was the answer?
The mesh analysis answer was 0.5.
Point? 0.5. Okay, let us see with the other students. Boys here, anybody who has done this by using mesh or node analysis? I tell you the equivalent circuit, the Thevenin equivalent circuit should be drawn like this. That is VTH. Here we have RTH, and here we have the load resistance RL. And VTH is nothing but VAB. If anybody has done using node or mesh, please let me know. You have done something, this one? Thevenin, you drew it a mesh analysis or node analysis. Otherwise, how we will verify? Here, anybody has done? You? Huh? Java. Yes. Thevenin direct करना, not source transformation करी पारिबो, you can do. When it is defined that you using by Thevenin theorem, now you find VAB by any method. You have to find VAB first. How much you get VAB? Have you done? You do with the mesh analysis. Those who have not studied the Thevenin theorem, they can do this problem using mesh or node analysis. How much you get? No one. If you have done using the Thevenin theorem, then please verify which one you have done. Node. Show me. Where is which one is a sink? Which one is a node you have taken? Which node you have taken? This. So, mention here V1, V2, V3. Otherwise, how do you know?
If we take these two nodes, what if VV minus VC minus 10 it will take, by 0 it will take if there is no resistance.
If there is no resistance, you need not to do the calculation. Rather, you can directly write VC minus VB is 10.
VC will 10.
This problem is actually you have done it you have given a problem, but it's in 3 meshes there, so it is actually lot of calculations will be there. Otherwise, that problem is okay. So I'm going to rub this side of the problem so that I will get a space, and I will just recalculate the same problem using mesh analysis. Okay. Okay, we are solving again this problem by using the mesh analysis. So usually in the mesh analysis you can choose the current. There we have choose anti-clockwise just for the favor, like 2 only mesh are there. Here we have 3 mesh. So there is no point of choosing any anti-clockwise. So let us say everything is in clockwise. And what are the equations we are getting? Let us do it. First, you imagine that there is a current source. So imagine that the voltage across this current source is Vx. Then write down the three equations. Equation for mesh 1. Equation for mesh 1. It is I1 plus 2 I1 minus I3, very good, plus Vx is equal to 0. Equation for mesh 2, you have to write equation for mesh 2 minus Vx minus 10 plus 5I2 is equal to 0, equation 2. What is equation 3? Equation 3, mesh 3, again it is minus 20, then I3, then, very good, plus 10, then plus 2 into I3 minus I1 is equal to 0, right? So we have got three equations. So what we can do, we need another equation. The another equation is this one. I2 minus I1 is equal to 5. So we have got four equations. Is this four equations understood to everyone? Please check your four equations when you do the mesh analysis. Is this the four equation you get? If not, please you can argue with me, or any equation you not understood, please argue. Have you got the same equation, beta? Have you got the same four equations? Sure. Okay, let us please solve. Somebody solve it. Now you solve these four equations and tell me what is the value of I2. We are interested only for the I2 here. Please solve these four equations quickly. First of all, add equation 1 and 2, Vx will be eliminated. Solve this. First verify is the mesh equation is correct or not. These four equations are you getting or not? Likhichu mesh equation. Kebe likhiu? Huh? Bododa khel leke. Very good. Likho. You solved it. How much you get?
Initially, I had solved it using the superposition.
Okay, whatever. You solve this four equation. Quickly solve now.
From that, I had got that 0.5.
Okay, now you solve this four equation. Quickly. How much you get? Check. I2 is 30? 35 by 8 you are getting. Or let us see others how much you are getting. How much you are getting I2? (15 by 4). Okay, one of you got 15 by 4. (15/4). Others? Equations are there, just you need to solve it up. Okay, one more. How much you get? 15/4? Okay, that means we are correct. Sorry. All of you may have attention, please. Everybody watch here. I will explain you the Thevenin theorem. Already we have done, just I will explain you the Thevenin theorem in nutshell. See, whenever you get a same problem over from there, same problem is here. The load is 5 ohm, right? So it is mandatory that when you solve it through Thevenin theorem, you must find out what is the value of RAB and VAB. RAB and VAB. RAB is nothing but RTH. VAB is nothing but VTH. So first you remove the load, and when the load is removed, you can choose any one terminal as A and other terminal as B. Please mention it. So I shrink the A terminal on this node and shrink the B terminal here. So name of the node, this one is B and this one is A. First of all, I redraw the same circuit here to find out the value of RAB, that is RTH. For that, what we did, we replaced the source to its internal resistances, to its internal impedances. In DC, it is internal resistance. So these two, what is the internal resistance of a current source? Infinity. So it is open circuit. You can see this is open circuit. What is the internal resistance of the voltage source? Ideal voltage source? 0. So that means this line is short circuit. Here also the internal resistance of this voltage source is short circuit. So after redrawing the same circuit but replacing their replacing the voltage source with short circuit or its internal resistance if given in the examination. If nothing is given, it is 0. And replacing the current source with the internal resistance, that is infinity if not given. So it is infinity, that is 0. So now what is the equivalent resistance? 2 and 1 is in parallel and that is in series with 1 ohm. So together what is the value of RTH? 5/3 ohms. Clear? Next we have to go for finding what is VAB. You need to find what is the value of VAB. So VAB is nothing but the same as the Thevenin resistance. It is the same as Thevenin resistance. So how to solve it? So we have to remove the load first. Then I shrink the node A. This one is node A and this one is node B. Now nothing to do with this node. We can use node analysis or mesh analysis to solve. What we find it that it is 2 mesh. If I take it number of nodes, it will be maybe it is more than that. So anyways, let us solve it by using if we use a node analysis also, it has only one equation. I think it is very easier than that. Okay, anyways, if we use a mesh analysis, you can take a 2 mesh current I1 and I2 here. Since this current source is there in this mesh, so the current value of I1 is 5 ampere, nothing else. And here I2, you need to find out the value of I2. As per usual convention, we start and take the first sign. So minus 10, here plus 1 into I2, here plus 20, and here plus 2 into I2 minus of I1 and equal to 0. So that we have written here. We solve this same equation once again. We find I2 is equal to 0. Then what is the value of AB? If you move from A to B like this, there is a current source. So voltage across the current source is again a question to you. So better is you can move like this. Somebody say, sir, I am not interested there, rather I will move like this. No problem. All the way you will get the same answer. So when you move like this, so it is 10. This is 2 into I1 minus I2. And this one is 1 into I1. And that's what we write here. And we get the value of VTH is equal to 25 volts. Now, once you get the value of VTH and RTH, then the equivalent resistance you need to, equivalent circuit, you need to redraw like this. Thevenin resistance, Thevenin voltage source will be written like this, VTH, and this is RTH, the Thevenin resistance, and the nodes are A and B. Is it okay? So what exactly you have did, you did, why somebody will ask me a question like why we are learning Thevenin equivalent circuit and all these things, why we are learning. So you will answer to them that if a big network is there, and we are interested only to find out what is the current through the load. So why not replace the entire network in terms of voltage source and equivalent resistance. So that's why this entire network, this entire thing has been replaced by VTH and RTH, and the load is there as it is. So this is the load and that is RL. So what is the current through RL? The current will be equals to VTH by RTH plus RL. So if anybody knows how to solve using mesh and node analysis, he can easily solve using Thevenin theorem because it's just a extension of that. Is it clear to you? So here we solve the same problem by using Thevenin theorem, and here we did it by mesh analysis. Mesh analysis we did just to verify that our answers are correct or not, right? So if you do with node analysis, you get the same answer. No need to do the same thing, all this thing again. We will take some another problems. Okay, yes.
In Thevenin theorem, for so since 5 ampere current source was there, directly I was switched to 5 ampere.
I'm not getting once again.
So in the first loop,
Huh.
since the current source of 5 ampere was present, between I1 is equals to 5 ampere directly.
Correct.
So how does that change in the mesh analysis here?
Okay, thank you. Sit down. This circuit, we have got two meshes here. So one is I1 and I2. This current source belongs to only this mesh. That's the difference. However, here this current source is sharing between mesh 1 and mesh 2. So I cannot say I1 is equal to 5. Neither I can say I3 is equal to I2 is equal to 5. So that's why this current source is assume that the voltage across the current source is Vx. When we write the equation for mesh 1 and mesh 2 and we add it, you find that Vx is cancelled out. You can use super mesh also, where you can make the super mesh like this, neglecting this middle one. Or you can take this one, this mesh and then add it, it becomes a super mesh. I will prefer this because this is very simple, to the point. You go for mesh 1, go for mesh 2. If there is a current source, don't worry, replace it by Vx. Where the arrow is going, you can say this is a plus, and where is arrow starting with minus. Replace it Vx, write down the equation for mesh 1, for mesh 2 and mesh 3. And then with 3 equations, you need another one equation. That equation is, since the direction of the current is upward, I2 minus of I1 is current source, right? So this is the way we can solve. I think it's okay. Okay, like that you can solve any problem. Suppose the same problem is asked to you using superposition theorem, right? Superposition theorem, if some problem is asked, it is very, very easy again. Why? In superposition theorem, at one time you will choose only one source. So what you will do with the rest of the source? You will convert the rest of the source with its internal resistances. Attention, hey, listen here, beta. कौन हला? Did you get the same answer? Any doubt? Any doubt is it? No? Okay. In case of superposition theorem, you can solve the same problem using superposition theorem, where in case of superposition theorem, you have to keep one source at one time. Suppose I want to find what is the current through which one? 5 ohm, right? So if I want to interested for what is the current through 5 ohm, I will keep one source at a time and I will draw 3 different circuits. I will draw 3 different circuits from the same circuit, okay? Okay, first I will keep only 20 volts, then I will keep 10 volts, then I will keep only 5 ampere current source. And I will draw 3 different circuits. Okay, and rest of the circuit I will replace by its internal resistances. So let me keep only 20 volts and other things as it is. This is circuit 1. Circuit 2, I will keep here only 10 volts and rest of the source will be converted into its internal resistances. So 5 will be there as it is. This is 1 and here it is 2. This is 10 and this one is 1. Next we will have the third circuit. See, 3 circuit we have drawn. If anybody has any doubt, please ask me. One problem, what we have done in case of superposition theorem, we have taken one voltage source at one time. So we have taken 20 volt source and drawn the circuit figure 1. Then we have taken 10 volt source and redraw the circuit. Then we taken 5 ampere source and redrawn the circuit. So we have got I1, figure 1, figure 2, figure 3. Quickly draw this and tell me, in case of figure 1, what is the value of the current through 5 ohm? In case of figure 2, what is the current through 5 ohm? And for figure 3, what is the current through 5 ohm? यहाँ से दिख रहा है? Draw करो तीनों circuit को जल्दी, quick. Every draw it within 1 minute. Come on. Draw कर बाबा. Everybody draw this 3 circuits and tell me what is the current through 5 ohm in figure 1, in figure 2 and figure 3. Quick. Huh? These two are, which one? Write down here, 1, 5. 1 and 5 are in series, 2 is in parallel with 1 and 5, then 1 is in series with that. Huh? You write, draw, calculate it, I will tell you. What is the voltage source? You write down 20 volts. Solve it. You do it yourself in the copy. Draw these 3 circuits and find out the current in figure 1, current in figure 2 and current in figure 3. This is you will do and tell me the answer. This side you do with the current in figure 3. Quick, current in figure 3 you find out. By the time I will take the attendance, Today date is 10, no? List of absence. Okay, roll number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Roll 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 47, 48, 49, 48. You are 49. 50, 51, 52, 52, 53, 52, 53, 54, 55, 56, 55, 56, 57, 58, 59, 59, 60, 60, 61, 62, 63, 61, 61, 60, 61, 62, 63, 64, 65, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 74, 75, 76, 77, 78, 78, 79, 80, 81, 82, 83, 84, 85, 84, 85, 86, 87, 88, 89, 87, 87, 88, 89, 89, 90, 91, 92, 93, 94, 93, 94, 95, 96, 95, 96, 97, 98, 99, 100, 101, 101, yes, 100, 101, you are 102, 103, 104, 104, 104, right? Yeah, 104. Anyways, there. 105, 106, 105, 106, 107, 108, 109, 110, 111, 12, 13, 113, 14, 114, 115, 16, 17, 18, 118, 119, and 20. Yeah, who is there? Whose attendance? Anybody's attendance is wrongly done? Roll number? 97. Okay. 98. 90? Who is 98? You are 98. 94. Is all right? Take a photograph. Okay, what is the solution here? How much you get for figure 1? I think by now you have done it. What is the current in 5 ohm resistor in this figure? 2 ampere. Okay, one of your friend is saying it is 2.6 ampere. Okay, in figure 2, how much? You are saying 2 ampere. Okay, your friend is saying 2 ampere. Okay, here, no, 1 ampere. Okay, your friend is saying this 1 ampere. This one, how much? Here, how much you get? करीनो कहीं बुझेला attendance tension through. What is the current through this 5 ohm resistor, right? So this circuit is, you redraw the circuit jodi bujhiyo ne, right? This is 2 and 1 like this, right? And 10 and 5 is in parallel series, right? Right? This is like this, and this is 20 volts. So the current, whatever current is here, is current division rule. So first you find what is the total current. So this is 5, 10, 15, 15 and 2 is in parallel, right? So 15 into 2 by 15 plus 2, 17. Then 1 is in series, so plus 1. What is the equivalent resistance you find? How much? 30 plus 17 by 17, that is 47 by 17. That is the resistance, and voltage is 20 volts. So what is the total input current? 20 divided by 47 into 17, right? This much voltage, this much current. So current division rule, the current which is flowing in this branch is the opposite resistance. So the current which is flowing in this 5 ohm resistor is 2 divided by 2 plus 15 into the total current, 20 into 17 by 47. So this 17 cancel out, 40 by 47 is the answer. Yes. So similarly do the second one. This one is coming 40 by 47. There. Are you getting the same here? How much you get? Please check that. Verify that one, whatever you get. This one is not 10, this is 1. So you might have got a wrong one. For here, he has written here 10. That is why he got different answer. This one is 1 ohm, na? How much you get here? How much? Do you want me to solve this? Okay. These two are in series, right? So this is 5 plus 1, 6. 6 is in parallel with 2. So what is the equivalent resistance? 6 into 2 by 6 plus 2. That is 8 divided by, 12 divided by 8. How much it is? So 3 by 2, right? It is in series with 1 ohm resistor. So 3 by 2 plus 1. How much it is? 5 by 2 ohm total. And what is the voltage here? 20. So what is the net current? 20 by 5 by 2. It is 8 ampere, right? Use the current division rule. The current through 5 ohm is equal to the opposite resistance, that is 2 divided by sum of the two resistance. 2 plus 6, that is 8, into the total current is 8. So the answer is 2 ampere. Please verify. Is it 2 ampere? If you have done mistake, at least you learn. If you have not tried and you just copied here, it is of no use. That's why I said please attempt that. If mistakes, you are learning something, that's a good thing, right? Okay, similarly, can you solve for this one? Can you solve for this one? What is the current for 5 ohm? Zero 0.5. You are saying the value of I25 is equal to 0.5. So this is 2, this is 0.5, and this one is, what is the actual current here? 15 by 4. So 15 by 4 is how much? 3.7. So already you get 2 ampere there, 0.5 here. So you please solve it. You know the answer. You find out what is the current in this 5 ohm. Kitna? How much? 5 by 4. Did you calculate that? So 5 by 4 is how much? 1.25. So 2 plus 0.5 plus 1.25. How much? 3.75. That's superposition theorem. So in a linear network, you can use this superposition theorem, and the easy thing is that, the good thing about it is that if there are multiple sources are there, you can use any one source at one time. Is that clear? And redraw the circuit. That's all.